This page is in your notes packet, and this is where our examples are going to come from, and also your homework problems will come from this sheet. There's not really room to write our answers on here, though, so I would suggest taking notes on just a sheet of paper. And again, the better you take your notes, the easier your homework might be for you, because you'll have something to look back and model your answers after. I'm going to just put up a whiteboard to do all the problems on, but this is where our problems are coming from, and this is where your homework problems will be coming from tonight. The first one we are going to look at together is problem number 1. Problem number 1 says that we have a given of m parallel to n and angle 2 congruent to angle 3. We are trying to prove angle 1 is congruent to angle 3. We also have a diagram.
Do I have to draw the diagram if I'm doing this on a separate page?
When you do your homework, you do not need to write out your given and draw your diagram. You can just write the body of your proof. If you think it might be helpful to you to write all of that out, that's fine. I'm going to be writing them out as we go through our examples. But as you do your notes and as you do your homework, if you want to just write the body of your proof, the statements and the reasons, that's okay. That's all that we're going to be taking grades on. So that's all you need to write on your homework. Okay, so to do this proof, a good place to always start is the given. So we're going to start with m parallel to n, and angle 2 is congruent to angle 3 as our given.
Question.
Yeah.
When you write parallel, are you supposed to do like on an angle like that?
Slight angle. Yep, they don't stand straight up, it's on the slight angle for the parallel symbol. I like to mark my diagrams with what I'm given so I know what I already have, and that can help me see where I might want to go from here. So I'm going to mark m and n as being parallel. Yesterday we learned that we can put those, or maybe it was 2 days ago, we can put those little arrows on there, and that'll say things are parallel. And then we're told that angle 2 and angle 3 are the same size, so we can put a little mark in those to show that we know those are the same. Our goal is to prove that 1 is congruent to 3. Okay, well, we can't say that yet, but if m is parallel to n, so one question I'm constantly asking myself in a proof is, so what does that tell me? So my given is that I have parallels. What can parallels tell me? When I look at those parallels, what do they tell me? That 1 and 2 are going to be congruent because they are corresponding angles. So the y is the other side of this. So 1 and 2 are congruent. Why are they congruent? Because they're corresponding. But we need to say if parallel, corresponding angles are congruent. Because corresponding angles are not always congruent. They're only congruent if the lines that made them are parallel.
Then you would put 2 is
This
equal
will be
to
done
3.
in 3, isn't it? This is going to be done in 3.
This will be done in 3. Because at this point we know 1 is the same as 2, which is the same as 3. So that means 1 is the same as 3. And what is that called?
Transitive.
Transitive. You could also say substitution. Transitive is the more specific word. Substitution is a more general word. But substitution would be correct. I wouldn't deduct for that. Okay? Questions? So your assignment tonight is going to be writing proofs. The longest that any of them have to be is 5 steps. Most of them are going to be more like 3 or 4 steps. So this is a good representation of what your problems are going to be like. But we're going to do several more examples here together. Any questions on this one before we go to our next one?
Nope.
Are you going to show us how to do a 4-step?
Yep, we'll go through several different types. So the next one we're going to look at together is going to be problem number 3.
What about 2?
I am going to skip number 2.
Do you want to do all of them? Or some of these in our homework?
Some of them will be for homework.
Yeah, because 2 would just basically be the second and third steps reversed. 2 is equal to 3.
You just should go 1 is equal to 2 and 2 is equal to 3 transitive. It's the same thing.
John's.
Alright, so this is what we have at number 3. We know J and K are parallel. So if I like to mark my diagram, I can mark those up. And I know that 4 and 7 are the same. So I can mark those both with an arc in the diagram to show they're the same. I'm trying to prove 5 is congruent to 6. A good place to always start is our given. So keeping our destination in mind, if I want to prove that 5 is congruent to 6, I haven't said anything about either one of those yet. So I should say something about one of them. What can I say about angle 5?
Congruent to 4.
It's congruent to angle 4. Why?
Alternate interior angles.
If parallel, alternate interior angles are congruent. 4 and 5 are alternate interior angles in that picture. We know our lines are parallel. So we learned a couple days ago that means our alternate interior angles should be congruent. So now I can add a little mark onto my picture there and say I know 4 and 5 are the same. Alright, so now I've got 5 in the problem. That's good. Keeping my destination in mind, if I'm supposed to prove something about 6, I should probably talk about 6. What can I say about 6?
It's congruent to 7.
It's congruent to 7. Why?
Vertical angles are congruent.
Vertical angles are congruent. We don't need any if parallel on that because vertical angles are always congruent, no matter what. There's no parallel lines in that part of the picture. So vertical angles congruent is just vertical angles congruent. So now I've talked about both of the angles I want to prove something about, and I need to see if I've said enough about them. So I want to be able to connect myself from 5 to 6. So 5 is the same as 4, which is the same as 7, which is the same as 6. So I was able to connect the dots. So I can say 5 and 6 are the same through either substitution or transitivity. Transitivity is the more specific, but substitution is still correct.
I don't know if it's transitive or substitution.
Transitivity is when we're setting up this equals this equals this equals this equals this. Substitution is if we're replacing just one part of a problem. We'll have some that will be substitution, and we'll see that happen.
What problem are we doing? 7.
Questions on this one?
Yeah, we're not done. Oh, yeah.
Yep, 5 and 6 is what we want to
I
prove.
was
So that
looking
is
at the given us a proof.
Right, the next one that we are going to look at together is going to be number 5. Number 5 is one of my favorite types of proofs. Did any of you ever read Choose Your Own Adventure books when you were younger?
What?
Where you get to
What?
like pick your.
Okay.
It's like, do you
So some of you read them, some of you haven't. So for those of you who don't know what these books are, you read for a little while, and then what happens is it's like you've come to a fork in the road. Would you like to take the left or the right? And then I'm like, oh, okay, well, I want to go on the right fork, and it says turn to page 52. So I turn to page 52, and I continue reading my story, and then it's like, oh, as you're walking down the road, you meet a dragon. Do you want to fight it, or do you want to run? And I'm like, oh, no, I want to fight it. And then you make your choice, and it tells you to go on in the story, and I would always end up dying. I apparently was bad at making choices, and so then I would flip back, and I'm like, oh, no, I didn't want to go right. I actually wanted to go left. And then I could go make other choices and try to get myself to a happy ending. This proof is kind of like Choose Your Own Adventures because there are so many different ways to do it correctly. I don't know exactly how many, probably not enough that everybody could do it differently, but there can be a lot of different right answers to this proof. There are a lot of right things to do, and there is one major no-no. So I will try to emphasize to you that major no-no so that you don't do that. But there are a lot of right ways to do this proof. We're going to start with our given because that's always a good place to start.
I didn't read this half of it for so many answers.
She'll probably grade it by herself.
Is that a W?
Yeah.
She's using her finger.
No, I know, I'm just making sure.
Yep. Yep, so our given is that we have some parallel lines. Then what I do is, since there's so many angles in the picture, I always want to keep my destination in mind because otherwise it's really easy to get on a buddy trail. So I'm going to circle 1 and H, and that's my goal, is I need to get myself from 1 over to H. So I'm going to start with angle 1. Since I want to prove something about that, I should at least start with something that I want to end up with. And then what I have to do is decide, where can I go from 1? And there's a lot of places I could go from 1. I could go from 1 to 6. What would I say there?
Vertical angle.
Vertical angles. I could go from 1 to 3. What would I say there? Corresponding angles. Or I could go from 1 to A. And what would that be?
Go from 1
That would be corresponding as well. What I cannot do, major, biggest no-no students do, is I cannot go from 1 to C. You must be traveling along a line. So you cannot jump from kind of one group of angles to a group that's diagonally away from it. You have to travel along a line. So I can't jump down to that lower right-hand corner. But going to 3, going to 6, going to A are all good and perfectly valid things to do. I'm going to go to 3.
Go from 1 to A.
And that's going to be if parallel, corresponding angles, congruent. So now I'm going to circle 3 because I got myself there. Okay. Then I have to say, okay, where can I go from 3?
C.
I could go to C. Where else could I go?
D.
I can't go to D. I could go to 8.
Oh, yeah.
I could go to 8 by vertical. I could go to C by corresponding. C was the first answer I heard, so that's where we're going to go. That I can get from 3 to C by if parallel, corresponding angles congruent.
I'm choosing my own adventure. I'm going to 8.
No, that's an angle.
An angle.
She just rounded her angle and sharpened her C.
Can we just put them in all in one step?
Since they have the same reason, we could put them in one step. I usually don't because I like to see my progress through, but it wouldn't be wrong since they have the same reason to put them in one step. All right, so my goal is to get to H. Can I get there from C?
Yep.
Absolutely.
Okay, why?
Vertical angle.
Vertical angles are congruent.
They always.
So then I got myself from 1 to 3, 3 to C, C to H, and that's where I wanted to get. So this proof is done. 1 is congruent to H. Why?
Because of transitivity.
Because of transitivity or substitution. We were able to set up a chain of this is the same as this is the same as this is the same as
What
this.
is that? What's the reason for 4?
Vertical angles are congruent.
I took my own path.
There are many different paths you can take. Some of them will be longer than others. 5 is the quickest path that we can take. Some paths will be longer than 5. I am never going to grade you on there was a quicker way to do it. Okay, the goal is getting to the destination. If you end up taking some detours or bunny trails, that's fine. I'm not going to mark you down as long as what you're doing is still right. Okay, but the major no-no on this type of a problem is jumping to a diagonal corner across the picture. You have to follow a line. Okay? Questions?
Is that the last one we're doing?
No.
Oh no.
The next one that we are doing
It's 7.
is 9.
I'm a bad
You are just awesome.
Before questions 9 through 12, the directions say in 9 through 12, it is given that parallel lines A and B are cut by transversal T. We can just say we're given that we have parallels. That's the really important part, that we have parallels. And in number 9, what we want to prove is that angle 1 plus angle 7 is 180. our picture is just kind of our standard lines intersecting picture, or lines parallel picture.
Hey Jordan, you know what my favorite proofs
Good place to start is with the given.
are? The ones that prove x equals.
I want to prove something about angle 1, so I should start talking about angle 1. What is something I could say about angle 1?
It's number taking.
It's congruent to 4. What else could I say about angle 1?
It's supplementary to 3 and 2.
It is supplementary to either 3 or 2, that those would add up to same straight lines. Or what's one other thing that could be helpful about 1?
5.
It's the same size as 5.
Yeah.
So lots of different things I could say about angle 1. The one that would be least helpful is vertical with 4. Right? It's not a bad thing to do. That'll just take us on a little bit of a bunny trail. It'll make it a little bit longer of a proof. It's not wrong. It's just not as helpful. What I'm going to choose to do
We got that.
is say that 1 is the same size as 5. 1 is the same size as 5 because if parallel, corresponding angles are congruent. We're using the equals and the m's instead of congruence, but that's fine. That means the same thing. Alright, so I want to prove something about 1. I got 1 in the problem now. I also want to prove something about 7, and I don't really want 5. So is there anything I can say about 5 and 7?
Yes, 5 is supplementary to 7.
5 and 7 add up to equal 180. Why?
All behind.
Because it's parallel.
I have no clue.
It's
That's a straight line.
Because they're in a straight line. What do we call that when we add two angles together and they make a straight line? Angle addition postulate.
That's all it was.
Angle addition postulate is when we're adding up two angles that are next to each other. And these two angles happen to make a straight line.
Is this 3.3?
No.
3.4?
We did
No.
3 yesterday. This is worthless.
Quiet down. Alright, if we look at what we said in step 3, it's a lot like what we want to prove, except I've got a 5 instead of a 1 there. But in the previous step, I said 1 and 5 are really the same thing. So I can just take that 1 and plug it on in there and make a replacement.
So that is substitution.
And that is substitution.
Could we call that transitivity?
We could not.
No.
This is strictly substitution because it's replacing just a part of a problem. Transitivity is when we set up equals, 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 equals. Substitution works there, but substitution is specifically replacing a piece of a problem. Okay. So since we're just replacing one piece of it, that is substitution.
Are we done?
We are not.
Oh, you're anxious today.
Questions on this one?
You said it was substitution because only one part of
Yeah.
replacement part. Just do substitution all the time.
The next one that we are going to look at is number 14.
So bad.
Absolutely terrible, Troy. Wrong with you.
What?
Not in the
I'll go on when people are listening.
Oh, I'm listening. I can talk.
Hi.
And that's actually impossible. Your ears and your mouth cannot work at the same time and have your brain both function both at once.
Can you do it?
It's impossible. Your brain
No,
cannot
it's
function
not.
both
I can-
parts to listen and
You
talk
can hear and talk.
fully.
Oh, yeah.
Not fully. You're not comprehending what you're hearing if you're thinking about what you're saying.
Yeah. I can play video games and listen.
That's not safe.
All right, in this one, we are told J is parallel to K, and we've got this picture. We're also told that angle 3 is equal to 4x plus 14, and that angle 2 is equal to 7x minus 15, and it says find x. Right? This is not a proof. It didn't say prove anything about x. It says find x. We need to solve for x. So to be able to solve for x, we have to be able to set up some kind of an equation. So we're told about angle 3 and angle 2 in terms of x's. What can we say about angle 3 and angle 2? They would be the same as each other. Because 3 is the same as 1, why?
Vertical angles.
Vertical angles. And 1 is the same as 2, why? Corresponding. So then 3 must also be the same as 2. So what we can do is say that 4x plus 14 must be equal to 7x minus 15. And then we need to solve this algebraically. Several things we could do to start it out. I'm going to subtract 4x because I like to move the x's and I like to keep them positive. But moving something else is okay as well.
Whoa.
Then I'm going to add 15 to both sides. And then I'm going to divide by 3. And at this point, a lot of students panic because it doesn't go in evenly, and that makes students really nervous. Fractions are good numbers too. They get kind of a bad rap, and students feel like if they get a fraction, it must be wrong. But fractions are numbers too. So they are acceptable answers. So 29 thirds, so that would be 9 2/3, is a totally okay answer.
Would you prefer improper fractions?
I prefer improper fractions because it's less work. Like, I already have that, so I might as well just leave it and call myself done with it.
I always think I'm wrong whenever I get that.
I prefer
I'm telling you,
mixed
it's okay. It's
numbers.
okay to get fractions.
First number is
It's improper.
We have one more problem we're going to look at together, and then I'll give you some information about your homework. The last problem that we are going to look at together is number 18. Number 18 says, write a demonstration for, which that's this book's way of saying proof. Write a proof for, and then it gives us a theorem. It says, if two parallel lines are cut by a transversal, interior angles on the same side of the transversal are supplementary.
Oh boy. What?
We have a theorem here. We weren't told our given in our proof, so we need to decide what those are. In a theorem, the if is the given, and it said if two parallel lines are cut by a transversal, so I need some parallel lines. I should then draw myself a picture about what these parallel lines look like, and I'm going to use my classic parallel line picture. Yeah, for a problem like this one where no picture's given, you have to draw one. The then is the proof. So the theorem says then interior angles on the same side are supplementary. So in the picture, what would be a pair of interior angles on the same side?
4 and 6.
4 and 6 or
3 and 5.
3 and 5. Either one of those pairs would be fine. They are interior and on the same side. So 4 and 6 was the first ones I heard, so we'll go with those ones. And supplementary means they add up to 180. So that's what we're trying to prove about this. So now we're ready to write our proof. First step is given.
So we.
A lot of students want to just jump to step 2 and be like, oh, it's done, because we had a theorem that said same side interiors are supplementary. Which is true, we did have a theorem, but that's actually the theorem we're trying to prove right now. So that reason is off the table for this problem. Okay, that would be like me asking you, what does, I don't know, some particular word mean, and you say, well, it means, and you just say the word back to me. Right, that didn't actually tell me anything. So like, what does cytoplasm mean? And you say, well, it's the cytoplasm. And I'm like, awesome, I still don't know any biology. So we can't use that reason here because that's what we're trying to prove. So, I want to say something about angle 4. What can I say about angle 4?
It's vertical angle of 1.
It is vertical to 1. So I could say that. That'll take me on a little bit longer of a route. So what else could I say about
Let's
it?
do it.
It's not wrong. It'll just take us on a little bit of a detour.
Alternate interior angles with 5.
I could say that it's alternate interior with 5. So let's go ahead and do that.
Let's go.
The reason why I want to head down towards 5 instead of heading up towards 1 is because my destination involves angle 6. So I want to start heading myself in the direction of angle 6. So I'm heading downwards towards angle 6. So now, I want to talk about 4, and I want to talk about 6. I don't really want to talk about 5. What can I say about 5 and 6?
They're supplementary.
They add up to 180. Why do they add up to 180?
Angle addition postulate.
Angle addition postulate, because they're right next to each other.
Supplementary.
Shaggy.
So, if 4 and 5 are the same size, then I should be able to swap one out for the other. So I can take that 4 and plug it in where the 5 is. And that's our destination. Our reason is substitution.
Whoa. Oh, no.
On your homework, you will be doing, as well as a few others, which I will tell you in a moment, number 17, which, like this one, does not tell you your given, your proof, or your diagram. I would suggest just using the same exact diagram and the same exact given. Okay? The theorem at number 17 says that we want to prove alternate exterior angles are congruent. We have not defined alternate exterior angles, but using a gut instinct, looking at this picture, what do you think would be a pair of alternate exterior angles?
We can't use our eyes though. We have to know for sure.
I'm not asking you what's congruent, I'm just asking you what could we call alternate exterior?
So what are the problems?
2 and 7.
2 and 7 would be alternate exteriors. Alternate, so they're on opposite sides, and exterior, they're on the outside. Okay, so on number 17, you'd want to do this type of setup, and our goal is to prove that 2 and 7 are the same size.
What number do we do?
The numbers that you are doing for your homework are
In the written exercises?
not in the textbook.
Yeah, but there's the written exercises.
We're not doing
There aren't written exercises here. So the numbers that you are doing for your homework are number 2, number 4.
It does say written exercise on it.
You're on the wrong page. Number 6. Number 10.
Page 8.
Number 13. And number 17. It should say page A at the top. And those are the numbers that you are doing for your assignment
This
tonight.
might be an ugly grade.
Isn't it